Okay, so this is the chapter 4 content, which is mainly around graphs, different types of graphs, translating those graphs, transforming the graphs. So we'll start with some of the basic stuff, which is just the shapes of some types of graphs. So hopefully you know the general shape of a cubic. So it tends to have two turning points. It goes up, then down, then up, or it can go down, then up, then down, depending on if it's got a positive leading coefficient or a negative. So if you're trying to sketch a cubic, really what you want to know is its roots, so where it crosses the x-axis, because if it crosses the x-axis once, then that's how you're going to draw it. It's going to go up through the x-axis once, then the second turning point is not going to go through the x-axis, so it's just going to be one root. That happens when you factorize it. You've got, say, x plus 1, and then the second part, the quadratic, has no real roots. In this case, we've got 3 roots, or it's factorized into 3 binomials, and you can put each of these equal to 0 to find the 3 roots. So it's going to be x is minus 1, x is 3, and x is 5. So put those on your diagram first. So 1, 3, and 5. And then you want to draw the general shape of a cubic through those points. If you really want to know this axis where it crosses the y-axis, then you can. You just have to either look at it before you've factorized it, or you just want to know the final number, which you would get by doing 1 times minus 3 times minus 5. So it's going to go through the y-axis at 15. And then up, down, up, going through each of those points. To begin with, maybe this is going to be a bit of a mess, or if you try and draw it on a board, sometimes. Yeah, but you get that general cubic shape, up, down, and then up again. Thing to note is that this turning point here isn't at 4. This turning point isn't necessarily at 1. Did I put 1 there? It's minus 1. It doesn't have that symmetry that a cubic has, sorry, a quadratic has. For a quartic, you're looking again for the factorized form. So here's one I've factorized all of it. With a quartic, there's a few more options. The general shape is kind of a W shape, or if it's negative, it's an M shape. So you've got 3 turning points. There's a lot more options for whether it crosses the axis or not. So it doesn't have to cross the axis at all. It could do all of the W shape above the x-axis, but it could cross it once, twice, and then bounce off, in which case you'd have 2 brackets different, and then 1 which is repeated, so you'd have a squared. So if you get, say, x minus 1, x minus 3, and then x plus 5 squared, then that would touch x minus 5, or x is equal to minus 5, then go up and then go down and back through 1 and 3. So it's the same rules as quadratics. So if it says something squared, so like x plus 1 squared, that's going to bounce off of the x-axis. If it's just once, that means it goes through the x-axis. So here we've got x minus 1, so it's going to go through the x-axis at 1, x minus 3, so it's going to go through the x-axis at 3, x minus 7, so 7, and x plus 5, so minus 5. Put those roots on first. If again you want to know where it goes through the y-axis, multiply all these together. And in this case, we're going to get, 3 times 5, 15 times 7, is that 105? And it's negative because 3 of these are negative. So it's going to go through negative 105. My scale isn't obviously the same for x and y. But it's the general W shape. So I'm going to miss them now. But down, up, like this. Okay, this point here would be negative 105. It's minus 1 times minus 3 times 5 times minus 7, which I think is a negative 105. But that's the general shape. Again, if it's negative, it does it the other way around. So down, up, down, up. No, what do I just do? Up, down, down. There we go. So if this had a minus at the start, then it would be the mirror image of this. So put the mirror on the x-axis, flip it, it would go up, down, up, down. So let's get rid of that because that's not right. Reciprocal graphs are the last ones. Now a reciprocal graph, they all basically look like this. If it's just 4 over x or anything over x, as long as that thing is positive, it's going to look like this. If it's negative, then it's going to be in the other two quadrants, so quadrant 2 and quadrant 4. If it looked like this, 4 over x squared, that just means that it can't be negative, because anything squared is positive. So it's going to have this shape. Okay, that's basically it for reciprocals. They all look like that. And they don't cross the axes, so you don't have to worry about that. Moving on to the intermediate stuff, we have all the different transformations. So if you add, so if you start with a function, say this was our function, the cubic, if we add a to that, the whole graph moves up by whatever that add is. So if we've added 2, everything moves up by 2. So this point here, 15, would go up to 17. This point here would go from -1, 0. So that would be where it crosses the axis, -1, 0. It would go up to -1, 2. This would go to 3, 2, from 3, 0. This one from 5, 0 to 5, 2. So I said it moves up a. That's how it looks. If you're ever asked about coordinates, the y coordinate increases by a. Now if a is negative, that's obviously it goes down, and the y coordinate would go down. For f of x plus b, that's inside the brackets. Anything inside the brackets, you have to do the opposite of what it says. So if it says plus b, that means that instead of going right, it's going to go left. So sometimes you get these questions where it says f of x plus b. Let's say again, this is our f of x. And it says what values of b would make it go through the origin, for example. So f of x plus b, we're moving it laterally, sideways. So we could move it 1 to the right. So that would be b as -1. Or we could move it 3 to the left, or 5 to the left. So there'd be 3 values of b that would make this graph go through the origin. That would be b is -1, 3, and 5. So yeah, moves left b, and the x coordinates will go down by b. So if b is positive, they go down by b. If b is negative, then that's down by a negative, which is up. For the bottom two stretches, c, f of x, so we're multiplying f of x by a constant. No. So that means it stretches by a scale factor of c. So again, if it was this, it would stay the same basic shape, and it would still go through all the same roots, but this point here would be twice as high. So instead of being 15, if c was 2, I'm doubling it. If c was 2, then 15 would go up to 30. And this, we don't know that turning point, but it would be twice as low. So that stretches in the y direction. What that means is that the y coordinates are going to times by c. So if c is 2, they're going to double, but just the y coordinates. If we do the bottom one, so it's inside the brackets, it's the opposite of what you'd expect. So if this was f of 2x, that would be a scale factor of 1/2 in the x direction. So everything's going to move inwards by a scale factor of 2. So -1 becomes -1/2. 3 becomes 1 over, so 1.5, 3 over 2. 5 becomes 2.5. Everything gets squished in the x direction. And in terms of coordinates, you just divide them all by whatever the d is. Okay, so sometimes you get these questions where you're asked to plot it, or not plot it, but sketch it, like this question would be. And then they ask questions about where the points move, so what happens to the coordinates. And say, for example, it's been multiplied by 2, and then in the brackets it says -5. Then that means that the y coordinate, all of the y coordinates double, and all of the x coordinates move right 5, so add 5 to all of the x coordinates. And you can just keep them separate like that. Some things affect the x, some things affect the y. And don't mix and match those. Like if it's in the brackets, it affects the x. Outside of the brackets, it affects the y. The last thing I would say is about asymptotes. Asymptotes are lines on the graph where the graph approaches the line but never touches it. So for a normal reciprocal graph like this, the lines are x equals 0 and y equals 0. Now, if, for example, you were to translate that graph, so instead of being f of x, it's f of x minus 2, that would look like this, 1 over, just ignore the plus 4 for now, x minus 2. That means the whole graph has moved to the right 2. So instead of the asymptote being at x equals 0, it's at x equals 2. That one's quite easy to remember if you realise why there's an asymptote in the first place, which is the reason you can't divide by 0. So as things approach 0, positive things divided by very small values, so positive small values get infinitely large. So that's why it goes straight up. Like if you put into your calculator 1 divided by a billionth, you're going to get a billion as an answer. And the same thing from the negative direction. If you divide by negative a billionth, then it goes up, or down I should say, to negative a very large number. So that's why you can't divide by 0, so the bottom of this fraction can't be 0. So x equals 2, that's where the asymptote is going to be. And then the last one, plus 4, that's more obvious, I think. Everything's moved up 4, so it's gone from y equals 0, the x-axis, to y equals 4. And that is all for that chapter. I'm going to look at the homework questions now. Thanks.